Hello and welcome. Just thought this time we're going to try something different. I'm going to make a video instead of a blog post on this one because I think you'll probably get more out of it, and I thought it'd be quite an interesting change for once. So we're going to attempt to write a keygen for this keygen here, the FrogSek KGM, which is written in assembler for Linux platforms, and it's a level 2 difficulty, which means it needs a little bit of brain or luck. And spoiler alert, it just needs a little bit of brain. It's not a super complex keygen, to be fair. So I've got up a Linux VM where I've already run it, and we get asked for a prompt, well, for a login, so we're going to try and log in. And okay, so we have to have at least 5 characters, so I'll just do that, and we say serial file not found. We can now either go look at the data with the strings, or we can just look at the strings anyway and see if we can find a file path somewhere, or because we're right here and it's not really that hard, we can just do an strace, and that'll tell us right here that we need a file at var temp the game.serial. So let's create that file, and we'll try again. Sorry, I'm doing it through strace again, but now we see that the serial must be 32 characters long. Fine. So we're going to edit the file var temp the game.serial 32 characters. Yep. And chances are that the serial is not going to be all 3s. So as we expected, we got it wrong. So let's try again. But instead of trying again, let's load it up in Radare. And first thing we need to do is analyze the functions. So AF for analyze functions, because otherwise the call graph won't show us anything interesting. While we're here, we might as well have a quick look at the strings. Sure enough, we see that we have a very long string. We have the file name for the serial, and we have some more error messages, and then we have this weird string, which will become apparent very shortly, and then we have a success string. Hurrah! Jolly good. Right, let's go visual. Let's put the registers in for the hell of it. Okay, so here's our entry point. First things first, we have this little block here, which altogether makes up a interrupt call, or a syscall, with this interrupt AOX80. And the way these work is that the EAX, EBX, ECX, and EDX make up the arguments, or the setup for the interrupt. EAX contains the syscall number, EBX the file descriptor that the syscall is going to operate with. ECX will contain the message or the string or the argument that the syscall will write to with, and EDX is the number of characters. So in this case we have a syscall of 4, which is stored in EAX. So you can either go and look it up in a table, or, which makes more sense, is to actually use Radare. Oops, ASL. That's not what I wanted, is it? AS? Yes, ASL returns the name. ASL returns the name of syscall number 4. So ASL 4. Okay, so it's a write. So, and we're going to write to EBX1, which is standard out. So basically, it's going to print 26 characters of this string to standard out, which is our login prompt basically. Then we've got a syscall 3, ASL3, which is a read. Now the read is going to read our input into this address, which is currently contains HSTRTAB, which is a placeholder for the username or login name, as it were. Then we move on. We have our username is pushed into EAX, which is which would be 2 at this point, and then, oh sorry, it's moved into EAX. Oh sorry, no, sorry. Our username is then null terminated, so that the string doesn't go over, and is then pushed onto the stack. Then we call this function here, which, if you look at it carefully, you'll quickly recognize that it's essentially just looping over the string until it finds the null character, incrementing EAX all the time, and then returns. What does it do? It gives you the string length. And sure enough, we compare it to 5, and if everything's okay, we carry on. But it's easy to go through it like this, but it's even easier to go through it in, come on, graph mode. So where are we? Here we are. So we've compared our username length to 5. Everything is, if it's not 5, we end up in here, which is another write, and it's going to write the login must be 5 characters long at least to stand it out. So, and then we end up here, and basically if any jump from now on, that where we see 81AD at the end, like that one, they're all going to be, you've done something wrong and we're going to quit, because we're going to end up, oops, we're going to end up down here, where we just basically section end and we're done. So now that we're here, we're going to do a syscall 5, which is a open of, surprise surprise, vartump the game serial. We're going to zero out ECX, and then we're going to see if everything went okay. If everything went fine, we're going to end up over here, oops, over here, and we're going to do an a syscall 3, which is a read. I'm basically going to read the contents of the file into the empty address there, and then we're going to see if we've read OX20 or 32 characters. So this is our length check to make sure that everything's okay, or that we have 32 characters in the serial. If we haven't, we end up in here where we do a write of this serial must be 32 characters long, and we do the interrupt, we come out, and we basically end up in the same place, but the difference is going to be that we're going to not enter, give me strength, right, this loop here. As you can see, this green line here is basically, you will recognize as a loop. And because we're initializing ECX to OX20, we're going to be iterating backwards over the serial number, or over the serial string, and then EDX is going to be zeroed out here, because as we can see later, it's going to be incremented and iterate over something else. So coming in here, first thing we do is decrement ECX. So we're going to be at the end of this string, which, surprise surprise, is this serial key. So we're actually going to be, so ECX plus that address is going to be at the end here in that lowercase z. Then EDX plus this address is going to be the beginning of our username, because EDX in this instance is going to be 0 because we're at the beginning, we've zeroed it out. So these characters are going to be loaded into the upper and lower registers of EAX, and they're going to be XORed, and then the result is going to be an AL in the lower register, in the lower 8 bits, and is going to be compared to, which is going to contain, if you remember, our serial number from the file, also comparing it to the last character of the serial number in the file. If they're not equal, we come, so if they're not equal, i.e. if they're not equal is true, we come here and we print out wrong, try again, and we end up at our exit. If they are equal, then we're going to increment EDX. We're going to compare EDX to EDI, EDI being the length of the string or our serial. If it's below, then we carry on. We compare ECX to 0, and which means that our loop's finished. If not, then we're going to clear out EDX and start iterating over the username again. Oops, I keep doing that. Then, you know, we do that. We compare each character of our serial, and if everything's okay, we're going to jump down here where we print out, yeah, you did it, and then we're going to quit, and we've solved our serial. Well, we've solved our keygen. So we've compared, and everything's gone well. So let's recap and write our keygen. So I'm going to use user bin Python for this. I'm going to first, so the username is going to be the first argument to the program. I'm not going to do much error checking on this because, quite frankly, you know, it's like there's no point at this sort of level of thing. So we have a serial key, which I'm going to call, which is our, where did it reside? Anyone? Nope, it's the one up from this one. Here it is. So these are our two kind of bits for the recipe. So to recap, we now have to iterate over the serial key from back to front and XOR each character with the front to back order of the username. So we can write a lambda function for this. XOR words is lambda, that's spelled correct, and we're going to return an array of ord C XORed with the ord of S, so basically the hex values of the equivalent characters, for S, yes, for SC in zip SSCC. I think that's the right number of brackets. One too many. That's better. Right. Okay, so what that's going to do, so zip, for those of you who don't know what zip is, will basically take two arrays or two iterables and zip them together into a dictionary, with the first argument being the keys and the second argument being the values. So if you have two strings or two iterables, one that goes ABC and another one that goes 1, 2, 3, you'll end up with a dictionary with keys A, B, and C, and the equivalent values 1, 2, 3. So that's fine. So now we're going to encode them. XOR words. And we're going to take our serial key and we're going to iterate over that backwards. So we're going to reverse it as we pass it in. And we're going to use the username to generate the key. So, and then we're going to open a local file, the game.serial, because we're going to copy it into place later. I'm not going to write to the actual target straight away. As file handle, 4e in enc, so for every character in the encoded string, which we also have to iterate over backwards, writing it back out, because now the actual serial is backwards, but it's going to be read backwards, so we need to put it backwards round there. Yeah, you know what I mean. And write E, and then, like the good citizens we are, we're going to close the file, and we're going to chmod plus keygen, keygen dump. Nope. Yes, I need to actually give it a name, don't I? An argument. Oh yes. Oops. So we can't write the hex result, so we have to convert that back to a CHR or char. I have to come and write chars. And I will remember how to use the program I wrote. And let's hex dump the game serial. Ah, it's too short. It is 2468 characters only, which is not enough. And the reason for that is because this zip function will only use up the shortest amount, or the amount of characters of the shortest input. So in order to get around that, from itertools import cycle, and what that will do is we'll take the username, which will be the shortest, most likely in most cases. I mean, 32 characters. It's not going to be any longer than 32 characters. Is basically take the username, and when it hits the end of the iterable, we'll move the iterator back to the beginning of the iterable. So therefore, with some luck, no, that didn't work at all, did it? Why not? Cycle CC. Did I get it the wrong way? I did get it the wrong way around, because oops. There. That will look a lot healthier. Nope, I've got to actually run it, haven't I? There we go, hex dump. Yes, there we go. So that's 32 characters. So the game serial to var, whoops, tump. And then let's run the keygen again. Sorry, not the keygen, let's run the program again. Username, and we did it. So, just a quick recap. We went over the input-output routines, and we learned about kernel interrupts and syscalls in assembler for Linux. We read the serial from the file. We then use the username with the characters from the serial that's hard-coded inside the program, the serial ABCDEFG, in reverse order to XOR the two characters together, and which becomes the expected serial number. So basically all you need to do in order to generate a key is take the username, XOR the characters of the username with the serial key, and whatever comes out is the actual valid serial. So I'm going to put a link to the actual serial in the description, and hopefully you enjoyed that, and hopefully you found it interesting and useful, and maybe I'll do some more as time permits, because they are quite time consuming to make these videos, it turns out. I never expected it to be quite so time consuming, but there you go. So until next time, good night.